Are there any of those that you guys have a quick question on that you want to talk about? Number 2? The graphing or the constant increasing or decreasing? What part of it? The graphing or where it asks if it's constant increasing or decreasing? Okay, so for the graphing, the first part of that, since it's just a 2, what is that graph going to look like? Whenever it's just yeah, it'll be a horizontal line. So then how many pieces is that graph going to have? Total? 3. So for the sake of time, I guess, when you have that, just make sure, like, if it's just a number, horizontal line, and then the other ones, these circles were just there to help you. They weren't meant to be used in every single graph. And then the last one, that negative 3x plus 12. If you can't get your y-intercept on the graph, do you guys remember what part do you worry about? Like, how do you figure out the third part of that graph if you don't have your y-intercept? Yeah, you plug into the equation. So the first time, this graph is going to get cut off at a 3. So you plug a 3 in, so you get your negative 3 times 3 plus 12. What's negative 3 times 3? Negative 9 plus 12? 3. So then you go over on your graph and you plot your point, and then you know that that point is on your graph. And if you know that point is on your graph, with a slope of negative 3, how do you always get to your next point? Down 3 over 1, down 3 over 1. So as long as you have one point on the graph, you can finish out the graph using the slope. And then once you have that, intercepts are still the same. Yeah. Yeah, I like crappily tried to cover that up. Just for you to check, that's what your last 2 graphs should look like. And then this one having down at the 12, hopefully that isn't going to be an issue. It's just a little bit off. If it's just a little bit off, you guys are fine. The range on number 10 is kind of tricky because it just uses the 5, and then after the 5, it's from negative infinity to negative 7, but since that 5 is kind of on an island by itself, that's why it gets put by itself. And then here's what those 2 equations look like. So negative 2x, and then x is less than negative 2. And then 2x plus 1 when x is greater than and equal to negative 2. Those 4 graphs, so these 2 and then the 2 where you have to graph, that's the style that you'll have to do on your quiz on Wednesday. So no tricks with y-intercepts, nothing crazy, just pretty straightforward of can you graph it and then find your cutoff points. This worksheet, you have until what day to turn it in? Wednesday. So if you are ready to turn it in right now, you can. You turning it in is saying you get it, you're good. What I need everyone to do right now is either turn it in if you're ready, and if not, get your stuff for notes. So you should have your 3 graphs already glued in, 2 colored pencils or marker, something like that. And then we are going to use a Chromebook at the end of the hour. So if you guys could just grab a Chromebook and then kind of push it off to the side. We're not going to log in, but just grab it. If there aren't any more, go into Bundy's room and grab from the bottom of her cart. So if you can't find one in here, it's not working, whatever, just on your own, go into Bundy's room. Again, we're not using the Chromebooks till the end, so we are starting in the notes. What we're going to be looking at is how do you solve things graphically. So next to your first graph, you can copy down 3x plus 4 equals negative 5. And the weird thing about that is you guys know 3x plus 4 equals negative 5. Algebraically, you have solved that 100 times. So if you algebraically wanted to solve that, what would your first step be? Minus 4, like you know how to do those steps algebraically. But instead of looking at things algebraically, we're thinking this like graphically. What does it actually mean for something to equal something else? So instead of looking at this as just like one big equation, we're going to look at it in two different parts. Because when you have an equal sign, doesn't it mean the left side has to equal the right side? So we're just going to look at this. Instead of one, we're going to look at it, okay, left side. We know how to graph that left side, 3x plus 4. When you graph 3x plus 4, where does it start at? 4. So let's start graphing it at 4. And then how do you count out its slope? Up 3 over 1. So again, we're looking at left side equals right side. So we graph our left side, so that would be your first color. So when that's why if you guys wanted to then mark that, okay, so that's one of my colors. Now on the other side, we wanted to equal my right side. So how do you graph that right side if it's just -5? It's a straight line at what number? -5. So it's a horizontal line at -5. So rather than think of this algebraically, we're thinking of this as two separate graphs, two separate equations, and we're comparing them. And we want to know, when does 3x plus 4 equal the -5? So we have our left side, and we want to know, when does it equal the right side? If you're looking at two graphs, and you're looking for where they equal, how would that appear on the graph? Where do they equal each other? More, like, don't give me a number. You're looking for where the graphs do it. Intersect. So circle where they cross, because isn't that going to be where they equal? So if you just want to know, where does my left side equal my right side, it's where they cross. Here's like a kind of catch-22. Those cross at a point, correct? Like it has an x and it has a y. However, if you look at that original equation, what's the only variable up there? X. So to answer this, what's the only variable we need to give? X. So what x value do they cross at? -3. So rather than say like this is an equation, I'm getting x by itself, graphically we're looking at where do those equal each other. You can still check your answer. You can substitute this -3 in. I don't know why I put that other parenthesis. What's 3 times -3? -9. What's -9 plus 4? -5. So does my left side in fact equal my right side? Yeah, so graphically we're looking for where they cross, because intersections, that's their equality point. That's where they equal each other. Since this just has an x, that's why our answer just has an x. The reason we're going to look at these graphically is now it's going to morph into this equation. So same graph, we're not going to regraph this because it's the same thing. Now write that inequality down. So now it's going to be 3x plus 4 is greater than -5. So if we want it to be greater than -5, we know that on a graph, their equality is where they cross, because that's where they're both at the same point. Now we want to be able to know, okay, well, where is my left side going to be greater than my right side? So if you just think about these as lines, if something is greater, is it going to be above or below the other one? Above. So this inequality is saying, when is my slanted line above my horizontal line? So if we look at this graph, on the left side of this point, do you see how the horizontal is above the slanted? Yeah. So is there a point where my slanted line is greater than my horizontal? What point does it start being greater than? -3. So it's going to start at that point. And is it everything greater than that or less than that? Greater than. So we're going to write this in two different ways. It starts being greater than at -3. And it's going to keep being greater than until what number? Infinity. It's going to keep going forever and ever, because anything to the right of that point, isn't my red line higher than my blue line? So if you're asked to answer something in set notation, or interval notation, there's your interval notation, or it could just ask you for what inequality. So the inequality would be x, -3, as long as your x's are greater than or less than -3, will that inequality be true? Greater than, since that's not equal, that's not equal. So two different ways to write your answer of saying, when is that graph going to be above my other graph? You can still check your answers the same way. Someone give me a number greater than -3. -4 is not greater than -3. 5. Okay, so if I plug a 5 into this, what's 3 times 5? 15. 15 plus 4? 19. Is 19 bigger than -5? Yeah, so you can still check it out that way to make sure you have the right symbol. But instead of solving these algebraically, we're looking at a graph. Questions about that? So if this question had asked, when is this 3x plus 4 less than -5, instead of looking at the right side, where is it less than? On the left side. So once you have your graphs, you're looking at that relationship. Where it gets tricky is how do you get those graphs? So here's our next equation we're going to look at. -x squared plus 9 greater than 0. If you have a calculator, you should grab it. If you don't have a calculator, you should come and ask me for one and then tell me if you need one or whatever.
Yes.
No. Do you have one?
No, I can get one. But
You have one?
yeah.
Okay, so first of all, we are thinking this is two different parts. So we have a left equation and we have a right equation. So our right equation is just 0. So what kind of line is just 0? Horizontal line, where is that horizontal line at? Or it goes through the origin, it's just right there. So there's our first equation. And now our second equation is that -x squared plus 9. Does that equation have a slope and a y-intercept? Does it have a slope? X squared. X squared is not a straight line. Do you guys remember from algebra 1 what shape x squared looks like? Parabola? Yeah, it's the U graph. So we work a lot with parabolas this year. For now, we're just going to kind of go back to the best method. If you don't know how to graph something, you just make a table. So we're going to make an XY table to graph these. This is why it's handy to have a calculator. When you make a table, what's the easiest number to plug in?
1.
Easier.
0.
0. So I'm going to plug in a 0. And remember, when you plug in a 0, that negative is in front. So it's -0 squared plus 9. In orders of operations, what happens first? Exponents or like negatives in front? Exponents. Exponents are going to start first. These parentheses just show like grouping, so there's nothing inside for them to do. What is 0 squared? 0. And now the weird thing is this negative sign in front is just going to hang out because it's really taking it times the -1, so it's going to make it negative. What's -0? 0 plus 9? 9. So we plugged in a 0, we got out a 9. What would be the next good number to plug in? 1. So when you plug a 1 in, this is where you have to be careful. Orders of operations, you square it first. So what's 1 squared? 1. But then we're going to make it negative because of that negative sign in front. So it's really a -1. So it's -1 plus 9? 8. If we plug in a 1, what else should we plug in? -1. So -1 squared plus 9. So -1 squared is -1 times -1. 1, but then we have this negative in front, so what is it really? -1. So that negative happens after you square it. So it's -1 plus 9. Parabolas are symmetric, so you'll get repeat numbers like that. If you have parentheses and you use your calculator carefully, Can your calculator do all of this for you in one step? Yeah, so you have to make sure you know how to use the materials in front of you. So if you don't know how to use your calculator, that's something you got to make sure you ask. What would be the next good number to plug in? 2. When you plug in a 2, it'll be -4 and then +9. 5. If you plug in a 2, what else should you plug in? -2. What's -2 going to give us? 5. And then our whole thing is we want to make sure we're comparing it to 0. So we need to make sure our graph is big enough so we get points on 0. So since we're comparing this graph to 0, like that's our right side, we need to make sure we get points on here. So we don't have enough points, so what would be our next point to plug in? 3. So 3 squared, 9, make it negative, so -9 plus 9, 0. And then -3, what will that give us? 0. So this is all just orders of operations plugging into your calculator. If you just plugged in like -(squared plus 9 and changed what you had in these parentheses, your calculator will do it all for you. And then here's where like today is a combination of what we did on the first day of school and now what we're doing now. We want to know where my red graph is greater than my blue graph. So if you want it to be greater than, which one do you want above the other? My left side or my right side? The left side. I want this to be above, so it's greater. What portion of the graph is above 0? The top part. Isn't from like here to here all above 0? That is very similar to what we did on the first day of school. Because if something is above 0, if something is greater than 0, are the positive or the negative numbers greater than 0? Positive numbers. When you want to know if something is above 0, it really wants to know where is that graph positive. And we did that the whole first week. Where is the graph positive? It's positive when it's above the x-axis. So if you wanted to write where is this graph positive, where does it start being positive? -3. Where does it stop being positive? 3. So if you wanted to write it in interval notation, your answer is it goes from -3 to 3. If you wanted to write it as an inequality, since this has 2 dots, that's the two-sided inequality. Where does x start being positive? Where does it end being positive? 3. So we have done this before. The only difference is you have to make your own graph. So when we first did this, you were given this graph, and then remember you'd be like, okay, well, I want it to be above the x-axis. So then you would look above the x-axis, but now we're making our own graph. Questions on this one? We're going to do one more like that. So x squared plus 2x minus 8, and we want it to be greater than 0. Since we want it to be greater than 0, instead of thinking like that is the horizontal line at 0, but do we want this graph to be positive or negative if we want it to be greater than 0? Positive. So we know at the very end, we're going to look and see where is my graph positive. So we know we want it to be above the x-axis. We know we want it to be positive. So our issue is we got to graph this. If you are graphing something, first figure out what shape it's going to be. Since it's an x squared, is it going to be a straight line or a u? A u. What's the easiest number to start with? 0. Here's where your calculator can save you lots of time, because you're going to be plugging in and it's going to be 0 squared plus 2 times 0 minus 8. What is 0 squared? 0. 2 times 0 minus 8, -8. So there's your first point. 0, negative 8. What would be the next number to plug in? A 1. So if you plug it into your calculator, you will do 1 squared plus 2 times 1 minus 8. So as long as you use parentheses in your calculator, it can handle it all. What is 1 squared plus 2 times 1 minus 8? Negative 5. What would be the next number to plug in? Negative 1. No. What's negative 1 squared? 1. What's 2 times negative 1? Minus 8. So what's 1 minus 2? Negative 1 minus 8. So don't assume that 1 and negative 1 are the same. You will get repeat numbers, but it's not guaranteed to both be on the x's. So just make sure in your calculator, you just change whatever's in the parentheses. What would be another good number to plug in? 2. When you plug in a 2, what do you get? Agree, disagree, 0. So what would be the next number to plug in? Negative 2. So if you do not know how to use your calculator between today and Wednesday, you need to make sure you know how to use your calculator. That's why I would rather buy you guys a calculator for the year so that you have a calculator that you always know how to use, that's yours, rather than playing the game of I'm either on my phone, this calculator, that calculator, because as soon as the rules change on a calculator, you're putting yourself 2 steps back. When you plug in a negative 2, what do you get up? Negative 8. Are we starting to get our full U? Yes. What would be our next number to plug in? Negative 3. Since we're comparing it to 0, we need to make sure we get 0 on both sides, so we just got to keep going. Negative 3, what do you get up? Negative 5. And then what would be the last number we need to plug in? Negative 4. So we're just making sure we got both parts of our U. Since we're comparing it to 0, we need to make sure we get all the way up to 0. When you plug in a negative 4, what do you get out? 0. And the question we are being asked is, where is that graph greater than 0? So where is that graph positive? How many portions of this graph are positive? How many portions are above the x-axis? 2. Where's the first one? Negative 4, and then to the left or to the right? So that portion's above. What else is above? 2, and then to the right. So just like at the beginning, where if you want to know where something is positive, where something is bigger than 0, it's just above the x-axis. Writing this in interval notation, where does this portion start being positive? And where does it start? Left side? Negative infinity, because it's going to keep going all the way to the left, and it stops being positive at negative 4. And then where does it start being positive again? 2, so x is 2, and it's going to keep being positive until infinity. So that's interval notation. If you want to write the inequalities, we know that it gets cut off at negative 4, and then for it to be positive, is it using all the x's less than or greater than? Less than. And then on the other side, we know it starts being positive again at 2, and is it using all the ones less than or greater than? Greater than. So 2 ways to write your answers. Sometimes you'll be asked for the inequality, sometimes you'll be asked for the interval. So all we're doing is comparing the 2 sides. If something is greater than, you want that portion on top. If something is less than, you would want the portion that's underneath it. we have one story problem we're going to look at. You don't need to copy these words down, but I would copy down our equations and then the little picture we're going to have. Mr. Archer is 2.45 miles ahead of Mr. Lennon. Mr. Archer is running at an average rate of 5.5 miles an hour. Mr. Lennon is running at a rate of 7.75 miles an hour. Let X be the number of hours since they started running. Write an inequality to represent when Mr. Lennon will pass Mr. Archer. So we have two people racing, and they both have rates. What rate is Archer running at? 5.5. What rate is Lennon running at? Those are really important because your rate, if you know your rate, that's the thing that changes each time, right? So if you think of the slope formula, like mx plus b, your rate is the thing that goes with your x, because slope is just rate of change. So the two people we're comparing here are Archer and Lennon. So now you should start writing what I write down. And in the end, we want to know when Lennon is going to pass Archer. So in the end, who do we want to be greater than, Lennon or Archer? Lennon, because we want him to pass him, right? So if we want him to pass him, doesn't he want to be ahead in the end? And the moment they pass each other, so the moment they pass, are they going to be equal or not equal? Equal, because if they're passing at that moment, are they going to be at the exact same point? I'm going to start with Lennon's equation because it's actually a little bit simpler. Lennon, does he have any sort of a head start? No, so he's starting at 0. So when he just starts running, he's just going to start. So in 1 hour, how far will he run? 7.75. How would you find out what he does in 2 hours? Times it by 2. What about 3 hours? Times it by 3. So how, if you know his rate, how do you write his equation? Perfect. It's just 7.75x. Because in your y equals mx plus b, m is your slope, that's your rate of change. So whatever your rate changes by, that always goes with your x. Now Archer, what's his rate? 5.5. Perfect. So it's going to be 5.5x, and then why do we have to add the 2.45? He has a head start. So those are the two inequalities that we're comparing. If we want Archer and Lennon, I'm going to just, for the sake of time, we're just going to sketch this one. If I'm going to put Lennon's equation in green, where does he start at? 0, so he starts at the origin, and he's just going up. Where is Archer going to start at? 2.45. So he's going to start here, and then he's going to go up. So let's just circle, at what point in time are they going to be at the exact same spot? Where does that show on the graph? Where they cross. So this point right here is where they're going to be at the exact same spot. And then that kind of divides your graph into a left side and a right side. So what side is going to have Lennon ahead of Archer? So where is Lennon's graph greater than Archer's graph? The right side. So if you look at this right side, do you see how Lennon's graph is above Archer's graph? That means he's going faster. He's further ahead of him. So on your graph, anything over here, Lennon's winning. Before that point, who's winning in the race? Archer. So when you're comparing two inequalities and you're looking at which one's greater than less than, you just look to see which one's above, which one's below. Does that make sense? Okay, now we're going to go on to the Chromebook. And this is not in Classroom. You guys need to go to this website. In this class, you guys were all with me on the first day, I think, right? Like, you've all signed up for this?
I don't think this is
Yeah, because it was that dining problem. Probably not. So the sign-in page should look like this. Please do not Google Pearson and then just go to one of the hits. That was really the only issue we were having second hour, is go to that website. Don't just like Google it and pick the top one without reading to make sure you're at the right website. And then remember, your sign-in is going to be your Google login without the @mygfschools and then your Google password. So it is Google without. Brady, just head over to Bundy's room and grab one from hers. And then once you guys get in, you should see that you have 2 assignments from me. Once you get to see your 2 assignments, just give me a thumbs up. Job. Should look like this. This one you do not need to complete. I just put this here so that you guys could see what resources are available to you. So it says, how can you how can you use a graph to solve an inequality? So if you're given that equation and you want to know where is it greater than 0, that means do you want the portion of the graph that's above or below the x-axis? Above. So you want it to be greater than 0, it'll show you the graph. So if you look at that graph, if we want it to be above, is it the blue or the red portion? The blue, and then it gives you the answer both as intervals and as inequalities. So there are extra examples. The one thing, bottom right. You see how in the bottom right it says 1 of 4. That's how you proceed on to the next one. You don't exit or do anything like that. So if they are examples, you proceed on the bottom right. That's how you always get to the next page on these. Now we have a motorcycle and a car. So this is going to be like Lennon and Archer. And again, it'll give you an equation. So if you want to know where is the blue greater than the red, if you look at their graphs, is it on the left side or the right side that the blue is greater than the red? The left side. Exit out of this. And then you guys don't open anything up. I'm just going to show you it up here. This is different than what you see. But your homework is assigned online. So this is the first time this year that your assignment is online. It'll be turned in online. You will literally turn in no paper for this assignment. Everything is online for this one. The one thing I need you guys to be careful about is how you graph things. So I'm just forwarding on to an equation that is going to be similar to what you will see. Okay, right here. So if you have x squared, is this graph going to be a straight line or a u? A u. On this graph, you can always make these graphs bigger by hitting this like plus and minus sign. So if you can't see something on your graph, you can adjust it. And then here you can also click to enlarge it. Since your graph is going to be a u, you want to pick the tool that shows it's a u. In order to graph these, you make a table. Is there room on here for you to make a table? Like, does this problem tell you to make a table? No. So that's why we did these in our notes, so that you know, okay, if I need to graph this, I need to, step 1, make a table. So on your own piece of scratch paper, you're just going to make a table. What's the first number you always plug in? 0, and then you go from there. The nice thing about it, since you are on the U tool, as you start plugging in points and you get that 0 goes down to -12, you put that point, and then you plug in a 1, and you get 1 minus 1 is over there, and then you get that -1, brings you like here. As you put on your points, it'll make the U for you. So as long as you are on the U tool and you start plugging in points, it'll create the parabola. You don't need to worry about connecting them through. As long as you're on the U tool, it'll make the parabola, and then you can hit save, and it'll bring your graph over here so you can answer the question. So when you have to graph those, Just make sure you're on the U tool. And yes, on your own piece of paper, you're going to have to make a table. So just make your own table, nothing crazy, and then just put those points on there and it'll fill in the rest for you. Does that make sense about how to use that U tool? Since this is the first time that you have had homework on here, tomorrow is a work day. It's a review day. Your quiz is on Wednesday. What I would like you guys to do is you have about 10 minutes, is you're just going to work on this for the next 10 minutes. When you're done, or if you, like at the end of class, you can log into this at home outside of class time and continue to work on it. If you don't want to do it at home because you're like, I don't understand what I'm supposed to be doing, your review packet is on those back 2 tables. So then tomorrow in class, between this online and that review packet, you can work on whatever you want to work on. So if tonight you would rather work on that review packet, and then tomorrow you can do the online because the online is confusing for you, do it that way. If you can want to do the online tonight at home and then work on the review packet in class tomorrow, do it that way. But from here until Wednesday when you walk in, you have to get these 2 things done. So you can decide if you don't want to do the online at home, then do it in class tomorrow. If you want to work on the packet at home, perfect. So when you guys walk out of here, you should have part of the online done because you have 10 minutes to work on it. Plus, you should have that packet back there made, and they're both due Wednesday. So then tomorrow is just a work day. Does that make sense? So when you walk out of here, don't worry if you don't have the online done, because if you can't do it at home, when can you do the online if you can't do it at home tonight? Tomorrow in class. That makes sense? All right.